Assalamualaikum and hi, my name is Muhammad Zakwan Birozilan. So today our group will present about industrial refrigeration system in Malacca for performance, safety and sustainability. Moving to our core focus, let's look at the investigation and mitigation of refrigerant leakage, especially at a cold storage plant located in Ayakroh, Malacca. First, efficient issue. Efficient energy consumption in high kilowatt slash refrigerating ton ratio. Second, safety concern. Early detection challenge regarding synthetic refrigerant leakage, which is R410A slash R22 due to vibration in the compressor room piping. Lastly, community impact. Plant proximity to residential areas in Malacca demands strict emergency response plan. To address this issue, our strategy relies on three core pillars of sustainable plant development. First, personal safety, minimizing workplace accident for zero accident goal. Next, legal compliance, avoiding heavy penalties for government agency, especially for DOSH and DOE. Lastly, eco-responsibility, reducing the industrial carbon footprint and contribution to global warming. So, these pillars ensure our engineering fixes delivers long-term compliance and safety. Moving into phase A, let's look at the fundamentals of vapor compression, refrigeration. These cycles release on heat absorption mechanism to pull warmth from the cold place and reject it into the atmosphere. The critical driver here is the heat transfer medium, the refrigerant itself. Looking at the diagram, maintaining a strict balance between pressure and temperature parameter across the compressor, condenser, expansion valve, and evaporator inverter. If this balance disrupted by a leak, the entire thermodynamic cycle degrades.
Hi, my name is Muhammad Shanizam. Now, I want to talk about key mechanical component of the cycle. First, compressor, increase vapor pressure and temperature. Second, condenser, reject heat, converting superheated gas into subcooled liquid. Third, expansion device, rapidly drop pressure of constant enthalpy. And the last one, evaporator, absorb heat from the surrounding, changing low pressure liquid into vapor. Okay, now we go to thermodynamic analysis using the pH diagram. Process 1 to 2, compressing of saturated vapor. Process 2 to 3, heat rejection at constant condensing pressure. Process 3 to 4, throttling expansion process at constant enthalpy. And the last one, process 4 to 1, heat absorption at constant evaporating pressure. Okay, now we go to COP and mechanical waste. We calculate efficiency using the COP formula shown here. In practice, refrigerant leak drop suction pressure and cause several overheating. Furthermore, recharging liquid too fast cause liquid slugging, which can instantly shatter the compressor, reach valve, and break the crankshaft. And now my last part is ASHRAE Standard 15 and DOSH compliance. ASHRAE 15 is refrigerant safety classification based on toxicity and flammability. The second one, refrigerant concentration limit (RCL). RCL is maximum allowable gas concentration in an enclosed space before it causes asphyxiation risk to operators. And the last one, DOSH mechanical ventilation. Mandatory emergency exhaust system must be triggered automatically upon leak detection to safeguard the plant room.
Hi, my name is Balkis Umaira, and I will continue with my slide. Press B. Pre-maintenance safety protocols. First, Lotto system, isolation of electrical power source and pressure valve to prevent accidental energy release. Second, permit to work, written authorization required before initiating high-rise maintenance activity. Third, toolbox talk, briefing session to identify job-specific hazard at the work site. Next, personal protecting during gas handling. First, eye and face protecting, preventing cryogenic liquid splash that can cause permanent blindness. Second, cryogenic or thermal insulated glove, protecting the skin against surf frostbite. Third, respiratory protecting, specific gas filter respiratory or self-contained breathing apparatus for ammonia environment. Next, strength testing and tightness testing. 1. Testing medium. 2. Oxygen or compressed air prohibition. 3. Detection method. 4. Pressure testing. 5. Bubble test and electronic detection. Next, removal of non-condensable gas. Objective, pulling a deep vacuum to ensure the system is completely free of air and moisture. Moisture hazard. Water react with refrigerant and oil to form hydrofluoric acid, severely corroding internal components. Evacuation and dehydrator system. Using a high vacuum pump to evacuate triple A and moisture from the circuit. Prevent internal corrosion, ensure proper oil lubrication, and maintain high thermodynamic performance.
My name is Kuratoini Nawara Mirtizu Amri. I will present about safe harvesting of refrigerants. First, recovery unit. Extract from the system into dedicated cylinder without venting it into the atmosphere. Second, cylinder filling rule. Strictly filling recovery cylinder to a maximum of 80% liquid volume capacity to allow space for gas expansion due to ambient temperature change. Third, refrigerant recovery procedure, utilizing a dedicated refrigerant recovery machine to extract remaining gas into certificate cylinder. Crucial education to ensure zero emission of vent into the plant atmosphere during maintenance. Phase C, ODP and GWP matrix in industrial cooling. ODP means ozone depletion potential. Index of ozone layer damage, CFC/HCFC, a high modern alternative. GWP means global warming potential. Greenhouse gas heat trapping index relative to CO2. High GWP HFC drive the need for attention to environmental metrics of leak. Leak synthetics refrigerants carry high global warming potential and ozone depletion potential. The sustainability big picture by fixing structural leaks and applying proper gas recovery. We prevent direct atmosphere destruction and lower the factory overall carbon footprint. Environmental Quality ACT1974 and the Montreal Protocol. First, Environmental Quality ACT1974. Second, Kigali Amendment Montreal Protocol. Third, Schedule Waste Management. Four, Legal and Regulatory Complaints. Five, the Montreal Protocol. Conclusion: the sustainability of Malacca industrial cooling system relies heavily on the synergy between thermodynamic efficiency phase A, discipline, safe work procedure phase B, and green legal compliance phase C. That's all from us. Thank you for watching.